All right, shall we? Yes, shall we? Let's get started. Now, shall we go? I think now I'm ready now. Hi. Now I'm ready. We can go to the YouTube, and now we can get started. Now can. Good evening, everyone. Can. Good evening. Evening, everyone. So now we are coming to the GEP Basic Modular Bootcamp, and this is Teacher Mill. Long time no see, dear. Hi, everyone. Good evening. Good evening, everyone. And today we are coming to lesson 1. For lesson 1, we will focus on the words problem. All right. So for the whole bootcamps, right, let me just show you the section that we are having. So for today, we are going to the words problem, and we focus on the age problem and the chicken rabbit problem. All right, and then also for this Friday, we will also talk about the words problem, but in the queuing problem and the interval problem. That is on Friday, this Friday. All right, then in lesson 3, that we will talk about fraction, especially the fraction calculation. And in lesson 4, we will focus on the number theory. Basically, it's about the factor and multiples and also odd and even numbers. And in lesson 5, we will talk about geometric around the area and the perimeter. And for lesson 6, we are going to talk about the revision. We'll just review on some basic modular that we would have for the GEP math. All right. So thank you, everybody, and thank you, everybody, for joining us today. Today, the focus is on the words problem and majorly on age problem and the chicken rabbit problem. So let's take a look at the first thing first. All right. So first, I will just show you this is Mew and this is your favorite teacher Charlene. All right. So make a guess. How old is Mew now? You can just make a guess in the chat box. How old is Mew? Oh, oops, sorry. All right. Actually, Mew is this year. Actually, Mew is only 10 years old. All right. And what about Charlene? What do you think? Charlene is actually 4 years old. So do you know the difference between us? Since Mew is 10 years old and Charlene is 4 years old, so actually the difference between us is 6 years old, right? 6. What about last year? Last year, Mew was 9 and Charlene was 3. Will the difference between us would be like 5 since it is last year? Will the difference change? No way, right? No. The difference is still 9 take away 3, that equals to 6. Right? And continue. Let's go 2 years ago. 2 years ago, Mew was 8 years old. Good. And what about Charlene? Charlene was 2 years old. But what about the next one? The difference between us. The difference between us is 6 again, right? Good. So now you can just make a guess. What about next year? What is the age difference between us next year? It will still be 6 years old. All right. And what about 2 years later? What is the difference between us? It will still be 6. Well done, dear. So this is what we have. Actually, the difference of the two people's age would never change. Mew is 6 years older than Charlene. Then Mew would be forever 6 years older than Charlene. All right. This is something you need to remember for the age problem. This is one very, very important key. All right. So let's continue. Let's have a try first. It says Melissa is 4 years older than Sam. So what is the difference between their age in 10 years? That means 10 years later, what is the difference? Would it be A or B? You can just tell me in the chat box. Yeah, so easy one, right? Well done, dear. So definitely it would be Since the difference of two age would never change. So the difference never changes. Good. What about continue? Collins is 10 years old and Tina is 42 years old. What is the difference between them in their age in 5 years' time? That means 5 years later. What do you think? Is it A or B? Oh, well done, dear. Perfect. So many of you are getting it correct. Good job, dear. The difference between them is first 42 minus 10. Right? So the difference is 32 years old between these two people. And after 5 years, would the difference change? No way. So this is one of the very, very important key of age problem because the difference never changes. The difference never changes. All right. And continue. What about the sum? Look at the sum. 2 years ago, when Miu was still 8 years old and Shirley was 2 years old. So the sum between us is 2. Is 10. All right. 10. The sum is 10. What about last year? Will you stay 10? Of course not, because last year Miu was 9 and Charlene was 3. So the sum of us is 12. Why? Why is it so? After 1 year, right, 2 years ago and to last year, there's only 1 year later. Why the sum would increase by 2? It is well done, dear. Because after 1 year, Miu will increase 1 years old, right? And at the same time, Shirley will also increase by 1. So the sum of these two people would together increase by 2. Well done, dear. So this is something we need to pay attention to. Since we have 2 people, every year, Miu increase, Shirley also increase. So that's why it would be 2 years, all right? This is something about the sum. The sum of 2 people's age would grow up by 2 each year. All right, so let's just prove it. What about now? Now Miu is 10 and Charlene is 4. So the sum of us would be 14. So then again, it would be like 2 years. 2 increased by 2. Right? What about next year? The sum is 16. All right, since Miu increased by 1, Charlene will also increase by 1. So the sum would increase by 2. What about 2 years later? It will still be increasing by 2, right? Plus 2. All right, this is so easy. Well done, dear. And continue. What about this one? It says sum of Melissa's age and Sam's age is 10 now. This year is 10. The sum is 10. So what about next year? The sum will just increase by 1 or increase by 2. Please let me know in the chat box. Well done, dear. Excellent. Don't forget, dear, the sum of 2 people's age would increase by 2 each year. Melissa increased by 1, Sam will also increase by 1. So for the sum of the age will increase by 2. All right, this is something you need to pay attention to. All right, and what about this one? The sum of Jimmy's age and Sam's age is 15 now. What about 2 years later? What do you think? Will it be A or B? Great, dear. Miu will say 2 years, right? 2 years later, definitely will be plus 2. Am I right? No way. Why no way? Why? Because now we have 2 people. Jimmy increased by 2. At the same time, Sam will also increase by 2. So that's why it will be increased by 2 by Jimmy. At the same time, increased by 2 by Sam. So again, sum of 2 people's age will grow by 2 each year. What about the multiple relationship? 2 years ago, when Miu was 8 and Charlene was 2, so the multiple relationship between Miu and Charlene is, well, dear, is supposed to be 4, right? Miu's age is 4 times Charlene's age. What about last year? Last year would be, well done, dear. Last year would be 3 times, right? That is, Miu's age is 9 times of Charlene's age. What about now? Can I still say it is 3 times? No way, right? No way. So what should we do? Actually, for this one, so far we don't know what is it, but definitely not 3 times, right? Because if it is 3 times Shirley's age, Miu shall be 12 already, right? 3 times Shirley's age, I should be 12. But there's no way, right? There's no way Miu is 12 this year. No way. So for this one, we don't know. Continue. What about next year? say it is 3 times my age? No way, right? No way. Definitely not 3 times. What about 2 years later when Miu will be 12 and Charlene will be 6? So Miu's age will be 2 times her age. Well done, dear. So now the question is like, would the times, the multiple relationship change? Yes, definitely change. And it would change year by year. Which means when it is 4 times 2 years ago, definitely it wouldn't be 4 times for the other years. It would be 3 times last year. It would be 2 times 2 years later. But definitely won't be any other years. All right, this is something you need to pay attention to. Multiple relationship is only for one specific year. This is something you need to remember. So here we go, dear. So the age of Melissa is 3 times of same age now. Now this year is 3 times. Can I say next year is still 3 times? Can I say so? What do you think? Definitely cannot, right? No way. Just for example, now Melissa is 9 years old, and then Sam is 3 years old, right? Melissa's age is 3 times Sam's age. Next year, Melissa is 10 years old. Oh, so is it still 3 times of Sam's age, which is 4 years old? No way, because we know that times the multiple relationship can only be used for one specific year. All right, and continue. What about this one? It says the age of Jimmy's was 2 times Sam's last year. What about this year? Is it still 2 times? A or B? Well done, dear. Definitely a no, right? No, definitely no. No way. Since, right, last year it is 2 times. So the 2 times that multiple relationship can only be used for one specific year, which is last year. So let's just summarize. Let's just summarize for the age problem. For the age problem, number 1, the difference would always change or the difference will never change. Well done, dear. This is something you need to remember. The difference will never change. All right, this is something you need to remember. And continue. What about the next one? What about the times? That means the relationship. The multiple relationship can be used for every year or only one specific year. Well done, dear. It can only be used for one very specific year. 2 times this year, then it won't be 2 times any other years. Right? What about the next one? The sum of 2 people's age would go by what each year? Would go by 2 each year. All right. So this is something we need to remember. Right? Thank you, everybody. After that, let's just go to some questions. The question itself is not that easy, all right? So let's try, all right? Here we go. Last year, all right, you need to pay attention to the year that we are talking about because age keep changing every year, all right? So here we go, dear. So it says last year, the sum of Bob's age and Oliver's age was 29, all right? And then it says Bob will be 4 times as old as Oliver 2 years from now. How old are Bob and Olivia this year? Any idea? I see some correct answers in the comments now. That's so fast. Okay, guys, when we know the sum, right? We should just try to find out something else that we can do. For example, we have sum. We also have multiples, right? Which one we should start from? We should start from the sum or start from the multiples? Of course, we should start from the multiples because the multiples will change every year. That we know this year, we maybe do not know the next year. So we can just start from the multiples. All right, this is something you need to pay attention to. We shall start from the multiples. So let's start from the multiples. If we start from the multiples, then the model should draw for last year or 2 years from now. Any idea? Yes, we should draw for 2 years from now. Since the multiples will change, so we should start from the multiples, start from 2 years from now. If so, then let's draw the models. It says 2 years later that Bob's age would be 4 times as Oliver's age, right? That means when Oliver is 1 unit, then Bob would be 4 times, which is 4 unit like this. All right. Then what else can we do? Now we use the multiple relationships already. What else can we use? Well then, we still have another thing called sum, right? So let's just label the sum at the right. Can I say the sum here is 29? Can I say so? Why not? Why not? Why not? Why can't it be 29? The question said the sum was 29. Why can't I label 29 here? Well then, dear, don't forget the model we are drawing is for 2 years later. But 29 is the sum for last year. So we need to go to 2 years later, which is increased by 3. Am I right? Why not? Great. It is because Bob would increase by 3 years. At the same time, Oliver will also increase by 3 times, 3 years, right? So it's supposed to be increased by 6, which would make the sum 29 plus 6. That would give you 35. When the sum is 35, right? So can you just find out each of the unit now? Well done. We find out that it's 1, 2, 3, 4, 5. 5 unit that gives you 35. If so, then 1 unit is 7. Oh, I know. So for Oliver, the answer is 7. And then for Bob, you have 1, 2, 3, 4, 4 unit, which is 28. Am I right? Am I right? Why not? Why not? Why not 7? Why not? Most of you telling me the answer is 7. Why not? Don't forget, guys. What is it? It's 2 years later. 2 years later, yes, Oliver is 7. Yes. 2 years later, yes, Bob is 28. But the question is, how old are Bob and Oliver this year? If it is about this year, then what should we do? We should go back 2 years, which for Bob is supposed to be 26, and for Oliver, she shall be 5. So pay attention. For this kind of the question, for the age problem, you need to pay attention to which year you are exactly drawing about. For example, for this one, you are drawing for 2 years later. So all the numbers you label on the model shall be for 2 years later. All right. But what if it's about like the sum, right? The sum is for last year, then you need to make it into this year and to make it happen. And also you need to go back to the question. The question is asking for this year, so you should go back to this year. Right? So what about question 2? Let's try this one. It says Jessica's age is twice of Derek's age now. If Jessica's age 8 years ago is equal to Derek's age 6 years from now, how old is Jessica now? Well then, it's now. Everything is about now. So any idea? I'm waiting. I'm waiting for some of the answers. Where should we start from? You see, now we got multiple relationship, right? You also see that we have something I really don't know what is it. Any idea? Where should we start from? Definitely, we should start from the multiple relationship, because the multiple relationship is very, very sneaky. It changes every year. For this year it's twice. For next year it won't be twice, and we don't know what is it. If so, then we should draw the models for the multiple relationship. But then again, this model of the multiple relationship shall be for this year, or shall be for what? Well done. It shall be for now. Perfect. Since the twice is only for this year for now. So only for this year. And it won't be any other twice multiple relationships anymore for the other years. Correct? If so, then let's draw for now. It says Jessica's age, all right, is twice as Derek's age. That means Derek is the 1 unit and Jessica is 2 unit, right? Okay, then continue. Look at this very crazy sentence. It goes, Jessica's age 8 years ago. That means for Jessica, he need to take out that 8 years ago, right? Bye this 8 year. Bye. Then she would just reach by here, right? Then it says it's equal to Derek's age 6 years from now. That means for Derek, what should we do to him? Have 6 more, right? 6 more. Then they would be equal. Any idea? Well done! Excellent. Then you will find out that for one specific unit, there will be, this part will be 6, right? So for 1 unit is 6. For Derek, now he is 6. Ta-da! For 1 unit, right? So there's 6. That means, okay, so the answer is 6. Am I right? I can see some of the answers in the chat box tell me the answer is supposed to be 6. Am I right? No way. Why no way? Why no way? Great! Because 1 unit is not 6, dear. You need to know what you are looking at. You're looking at this part with the 1 unit is supposed to be 6 plus 8. That gives you 14 for 1 unit. Oh, yes, not 6, dear. So it's supposed to be 14 for 1 unit. Okay, now I know. So the answer is 14. Am I right? Also, no. Why not? Why not 14 then? We find out that 1 unit is 14, so the answer is supposed to be 14. Because yes, I know is this wrong, but you tell me why is it wrong? Because the question is asking about, yes, the other question is asking about Jessica. So guys, you need to read the question properly, all right? So for Jessica has 2 units, so it's supposed to be 14 times 2, that gives you 28. All right. Then again, for each problem, you need to always remember what you are looking at. You are looking at, like say, if it is asking for Jessica, so in the end, the answer is supposed to be for Jessica. And also, if you have the multiple relationship, we should always start from the multiple relationship for the correct time. Then we can just find out the rest of the clue to draw on the model, just like this one. 8 years ago and 6 years from now, so that you will find out that they make up 1 unit. And again, it's for Jessica. So go back to 2 units to find out. All right, which is like 28. Right idea. So for this one, thank you guys. Okay, one more. Then we go to one more crazier question. All right, let me just give you some secret. One thing is now Miu, right? Actually, Miu was 15. All right, when Miu was 15, then I will see Apple, your favorite teacher Apple, and she's 4. She's only 4, right? Don't tell her that I tell you this secret. All right. And then for Charlene was 5. Now the question is, how many years later, Miu's age will equal to the sum of these 2 teachers' age? Any idea? I will ask this one again. Miu was 15, Apple was 5, and Charlene was Apple was 4, and Charlene was 5. So how many years later the Miu's age will equals to the sum of the 2 teachers' age? Okay. I got several 3s. Oh, cool. Okay, let me show you. After 1 year, Miu would grow up by 1. Apple would grow up by 1, and Charlene will also grow up by 1, right? Okay, are we the same now? Is Miu's age equal to the sum of the 2 teachers' age now? Not yet, right? Okay, after 1 more year. 1 year for Miu, 1 year for Charlene, 1 year for Apple. Are we equal now? Still not, right? 1 year for Miu, 1 year for Charlene, 1 year for Apple. Are we equal now? Now it is 3 years already. Are we equal now? Not yet, right? Okay, continue. 1 year for Mew, 1 year for Charlene, 1 year for Apple. Not really, right? Well done. 1 year for Mew, 1 year for Charlene, 1 year for Apple. Good. So 1 more year for Mew, 1 more year for Charlene, 1 year more year for Apple. Are we equal now? Well done, dear. Now we are equal. Now Mew's age equals to the difference of the sum of these two teachers' age, right? Which takes me 6 years. So you will see, when after 6 years, Mew will grow up by 6, and Charlene will also grow up by 6. But what about the gap between us at first? It will just filled by teacher Apple, which is 6, right? So this is actually very easy. You can just direct look for the gap between us, right? This is the gap between Mew's age and those two teachers' age. Let me just show you again, right? This is the gap between us. Then for this gap, it will be filled by whom? I will just show you again. The gap is actually filling up by teacher Apple. So you can just direct find out that the gap, which needs 6 years, for teacher Apple to fill. So for teacher Apple, one teacher, she needs 6 years. This is very easy. All right. One more. What about this one? Now I got 3 teachers, all right? So again, Mew was 12. And this is Apple. This is, she was only 1. And this is Charlene. She was 3. And this is Jimson. Okay, long time no see teacher Jimson, all right? And he was 4. Again, how many years later the Mew's age will be equal to the sum of the 3 teachers' age? Any idea? So fast. I got some correct answer already. Well done. Okay, let me show you something. Cool. Okay, I will see that right now. These 3 teachers we got 8, right? Just now we also talk about we are filling the gaps between us, right? So let me just show you the gap. The gap's supposed to be here. So the gap here is only, like, say 4. So 4 years. I got some correct answers at 2. Why is it 2? Why is it 4? Okay, let me show you guys. All right, then again, right? Again, 1 year for Mew. 1 year for Jimson. What about Charlene and Apple? Will they stay the same? No, right? There will be definitely 1 more year for Apple, 1 more year for Charlene, right? Oh no, so look at the gap. Now the gap, is it shared by only 1 teacher? No. You will find out that now the gap is shared by 2 teachers. All right? Because Jimson would grow with Mew, canceling the growing up. But the gap between us will be filled by Apple and Charlene. Which then again, 1 year for Mew, 1 year for Jimson, 1 year for Charlene, and 1 year for Apple. Ta-da! 2 years done. So this is something we need to understand, that the difference between a group of teacher and a teacher would just decrease year by year. We need to find out the difference first and to think about that. Who are actually sharing the gap? Now let's try one question. Mr. Lee, okay, this is Mr. Lee, now is 63 years old. And he has 3 grandchildren, and their age is 9, 13, and 17. In how many years' time will Mr. Lee's age be equal to the sum of his grandchildren's age? Any idea? No idea. Okay. Currently, I cannot see any. Oh, I got some answers. Well done. Let me draw the models for you, alright? Since Mr. Lee is the grandpa, right? The grandpa and the children, alright? The sum of the grandson, alright? So Mr. Lee got a very big unit since he is 63 years old. Wow, so fast. Alright, and for the grandson, the sum, which is supposed to be 9 plus 13 plus 17, which is actually supposed to be 39. All right. Then what will happen? That would be the grandpa increased by 1, and the 3 grandson will increase by 1 for 1 grandson, for another grandson, for another grandson. So actually the difference of the gap is actually shared by how many children? Let me just show you again. What about 1 more year for grandpa? 1 year for one of the grandson, 1 year for another grandson, 1 year for another grandson. Actually, the gap of the difference is actually shared by 2 grandsons. Well done. So that's when we need to find out the difference first. For the difference, it's supposed to be 63 minus 39. That gives you 24. All right. Can I say it is 24 years later? Don't forget, 2 kids are sharing the gap. 2 kids are filling the gap. So that is actually 24 divided by 2 to find out it is 12 years later. Why is it 12 again? Because grandpas increased by 1. There must be 1 grandson sharing the gap, canceling the growing up. At the same time, 1 grandson filling the gap. At the same time, another grandson filling the gap. So actually, you have 3 grandchildren, right? 1 grandson canceling the growing up. Another 2 grandson sharing the difference. That's why you need to divide it by 2 to fill in the gap. All right, so easy, right? Thank you, guys. So let's just come to the summary for the first part about age problem. There are 3 key points of age problem. Number 1 is difference never changes. Number 2 is the times. That means the multiple relationship can only be used for 1 very specific year. And also, there must be sum of 2 people's age grow up by 2 each year. What if Naomi is asking, what about the sum of 3 people's age? Will increase by 2 each year also? No way, it will increase by 3, all right? What if the sum of 5 million people for the whole Singapore? So the sum will increase by 5 million each year, all right? So this is something you need to remember for age problem. After age problem, let's just go to the chicken rabbit problem. So for the chicken rabbit problem, it's about chicken and rabbits. Just in case you know nothing about chickens and rabbits, all right? Let's just go to some chicken rabbit first, all right? First thing first, I would like to ask, how many heads does a chicken have? Just in case you do not know, this is a chicken. So how many heads does it have? Of course, a chicken has 1 head. This is only 1 head, just in case you don't know, right? But then the question 2 is, how many legs does a chicken have? Well done. These are legs. So 1 chicken has 2 legs. All right, 2 legs. All right, thank you, dear. And continue. What about rabbits? How many heads does a rabbit have? Seriously, a rabbit has 2 heads? Crazy. No way. Definitely. Okay, I'll show you. This is a rabbit. And a rabbit is supposed to have 1 head. All right. And what about legs? How many legs does a rabbit have? 9,990 legs. Wow. Seriously. There must be, all right, 4 legs. All right. This is a very, very basic thing about chicken and rabbit. You must know. If one day we change it into ducks and cows, basically they're the same thing. All right. So here we go. Let's just take a look at the question. It says there are altogether 5 chickens and rabbits on the farm. Altogether, there are 14 legs in total. So can you find out how many chicken and how many legs? Now, how many rabbits? You try. Let's try. Okay. Let me just show you my method, all right? Currently, I don't have any correct answer. I don't know why. So let me just show you. The first thing first is, all right, since everybody, all right, chicken has 1 head each, the rabbit also have 1 head each. So 5 chicken and 5 rabbits altogether, they're supposed to be how many heads? Supposed to be 5 heads, right? Okay, so now we have 5 heads. We just draw this as a head. No matter it's a chicken or a rabbit, all right? What about legs? Can I put all the 14 legs on 1 head like this. No way, right? We are not drawing spider. It's not about spider problem, right? So we can just draw legs. For one head, how many legs we can draw? I can draw one. Only one? Seriously? Cannot, right? Either chicken or rabbit. Definitely there won't be only one legs, right? Okay, so there are two legs, right? Okay, two legs. Can I draw more? Can I draw three legs? No way, there isn't something called three legs thing, right? Okay, so can I draw four legs? Also can. So for each of the head, it can either with two legs or four legs, right? We don't know, either two or four. But can I just draw everybody two or four now then? No way, right? Okay, so let's just have a drawing method. Drawing method is very easy. I just think that everybody, at least, they must have two legs, right? Either two or four, so at least they have two. Then I will find out that if everybody got two legs, that means everybody is a chicken. So if everybody is a chicken, there's supposed to be 5 times 2. So now we got 10 legs, right? But the question told us altogether there are 14 legs, which means there would be 4 legs, which I didn't draw. For these 4 legs I didn't draw, where should I put them? Can I put all the 4 legs on one head like this? Makes it a crab. Can I? Yeah, definitely cannot, right? For the rest of this head, how many more legs we can give it? Yeah, you see that, right? Each of the rabbits can have 4 legs. Now we already got 2 more legs, so there must be 2 legs that we can give to each of the heads. For this one, 2. But not enough, right? I still need 1 more, 2. So now we have 5 legs, and we have 5 heads, and then 14 legs. So in the end, you will find out for this part, these 4 legs, they are actually for the rabbits. So we have 2 rabbits and 3 chickens. This is a very, very basic thing you need to understand about chicken rabbit problem. Right? It's about drawing method. But what about this one? Altogether, there are 50 chickens and rabbit. Altogether, there are 180 legs. Are you going to draw all the 50 heads and all the 180 legs to see how many chickens and how many rabbits? Don't use algebra. It's okay. There will be another way rather than algebra. Any other ways? All right, okay. Some silly thing that Mew can do it for you, all right, which is like I draw 50 heads. Now you see altogether there are 50 heads, right? Altogether there are 50 heads. Then what I did is I can just give them legs one by one, right? But at most, I will say at least each of the heads would have how many heads? How many legs? It must be 2, right? Because I can just first assume that everyone is a chicken. If I assume everyone is a chicken, then now I have how many legs now? I have 50 chickens, and each chicken got 2 legs. So altogether, I have 100 legs now. But then again, guys, in the question said, how many legs that we have altogether? 180 legs, right? That means we will find out that some of the legs we didn't have, which is altogether 180 legs. Take away those 100 legs we already have on each of the chicken. We have 80 legs that we still didn't draw. Then again, can I draw all the 80 legs on one head like this? So now this head is surrounded by 80 legs. Should I? Definitely not, right? We need to know for each of the heads, how many more legs can they have? That is what we call as the small difference. At most, one head can have 4 legs. Now we already have 2 legs already. So we can have 2 legs for each of the head, just like this, for the blue one. So how many such pairs of blue ones that we can add? Yes, so apart from doing it one by one, I can just use division. 2 legs for 1 pair, 2 legs we can add for 1 pair, 2 legs we can for 1 pair. So we can just use 80 divided by 2 to find out they are 40. 40 what? 40 40 of those which will have 4 legs, right? So they are actually the 40 rabbits. All right. So if the question is asking about chicken, then what should we do now? Use altogether 50 heads, take away these 40 rabbits to find out there are 10 of those. All right. So this is called the assumption method. How we assume? We assume that all animal is one type. For example, I assume everybody is a chicken. So now I got 50 chicken. 50 chicken shall have 100 legs. But then again, go back to the question. It says altogether there are 180 legs, which means, where are those 80 legs I don't have? Each of the chicken can have 2 more legs to make it into rabbits. So that's when we use 80 divided by 2 to find out that, we can have 40 those chicken change it into rabbits. So there are 40 rabbits and 10 chickens. This is called the assumption method. Let's try one by yourself. There are altogether 22 ducks and cows on the farm. And altogether they have 54 legs together. How many ducks and cows are there? Then you say, Mew, this is about ducks and cows. I don't know anymore. If I change it into, like, say, ducks and dinosaur, or ducks or crocodile, basically they are the same things. Do not use algebra. No algebra. Try this question by yourself. Currently I don't have any correct answers. First, let's just assume everybody is a duck. So if we have 22 ducks, how many legs shall be? Oh, well done, Aaron. Yes, there shall be. Each of those have 2 legs, right? So 22 ducks with 2 legs each is supposed to be 44 legs, right? But then again, the question says how many legs? 54 legs, which means we don't have enough legs. So we shall use 54 minus 44, go to 10 legs, right? Can I give all these 10 legs to one duck? Cannot. You need to find out the small difference. That refers to, now everybody got 2 legs already, and we still can have 2 more legs to become a cow. So it's supposed to be 4 minus 2 to get it, 2 legs each. If so, then can you just tell me how many such ducks we need to transform it into cows? We're supposed to use 10 divided by 2 to find out that there are 5 ducks transformed into cows. So we have 5 cows. If we have 5 cows, then how many ducks? Great. We use 22 minus those 5 cows to find out there are 17 ducks. So easy, right? Then again, this is called assumption method. So for assumption method, we assume all the animal is one kind. Find out the big difference. That means how many legs we didn't have. Then find out that each of the animals, how many more legs we can add in. Then use divisions to find out how many such more legs, pairs of more legs that we can have. But then again, in GEP, more type of the question is actually the chicken rabbit problem. Just like this one. It goes, there are 9 rooms for girls to live in. And there are 2 types of rooms, small rooms or big rooms. 2 girls can stay in each of the small room, while 6 girls can stay in each of the big room. Altogether, there are 30 girls in the dormitory. So how many small rooms are there? They say, Mew, this one is very difficult. Rooms. We don't have grills and rooms problem. Basically, they're the same thing. Do not use algebra. Try your best. Try again. Okay, let me give you some guidance, all right? Step 1. Step 1, we can just assume all the rooms were small. If all the 9 rooms are small, so how many girls can we accommodate? So fast. If all rooms were small, that means 9 rooms, all rooms were small and 2 girls each room. Altogether, we can only accommodate 8 girls, 18 girls. All right. But then again, well done, dear. But then again, altogether we have 30 girls. So that means how many girls that they need room to stay? Yeah, we have 30 girls. 18 girls got rooms now. So we still have 12 girls to accommodate, right? And these 12 girls, how many girls can get into the room at most? One room can accommodate 6, and one room can accommodate 2, right? The big one and the small one. So you will see that now for one bigger room, we can just accommodate 4 more girls for the small difference. 4 more girls get into the room and make it bigger. 4 more girls can make a room into a bigger room. So we can just divide to find out that there are actually 3 big rooms. Because these 4 girls are get into the room and make it bigger, right? So we have 3 big rooms. Hey, can I say the answer is 3 now? Why not? Why not? Because, well done, dear. Because it is asking about the small room. You have three big rooms. What about small rooms? We shall use altogether 9 rooms, take away 3 to find out there are 6 small rooms. So the answer is 6. Well done, some of you. Well done, everybody. So this is about the assumption method for chicken rabbit problem. Especially in GEP, we have so many questions. So when you recognize this is about, like, say, altogether, we can just split them into different things that we can just think of it is about the chicken rabbit problem. So for the chicken rabbit problem, assumption method, assume that all is one kind. Then we just find the big difference, like say how many more legs that we need to add in. And then find out the small difference, like say each of the head can have how many more legs. Then we just use divisions to find out. Thank you guys. This is about chicken rabbit problem. And this is about the worst problem for the first section. So from 7:40 p.m., that is from now on, you are able to do the daily challenge. For the daily challenge, altogether there are 5 questions. Once you submit, you will earn 200 coins. Sorry, it's about 200 coins for the daily challenge. And tomorrow in the afternoon, 12 p.m., that we will just release the extra bonus, which is 2 more questions, which is trickier. More challenging. All right, these 2 questions will be released tomorrow at noon. So you can just try this extra bonus. And once again, for the submission, you will earn extra 200 coins. All right. And this Friday, 7 p.m. is for the next section. It's about the worst problem 2. It's about queuing problems and interval problems, which is also a very basic topic that in G. Guys there, and thank you so much for today. Later, I will just publish the daily challenge and the extra bonus in the group. See you guys on Friday. Bye bye.